Yeah. Then angles in a triangle is 180. The exterior angle, which is D there, is equal to the sum of the two opposite interior. Isosceles triangles, they can be very handy when you're solving triangles because it means you only have to solve one side and angle, you know, one less side and angle to worry about because two of them are the same. Theorem here, the angle, this is a new one. These two are new ones. So the angle opposite the greater of two sides is greater than that means the biggest side is opposite the biggest angle and the smallest side is opposite the smallest angle. That makes sense?
Yeah, makes sense.
Okay, and then two sides of a triangle. This is the triangle inequality law. So if you have two sides, when you add them up, they have to be greater than the third side. So like from B to A to C is going to be bigger than going straight from B to C, say. Okay, because the shortest distance between 2 points, that's one side. And then if you, no matter how short the other two sides are, they have to be longer than that third side. Parallelogram, opposite sides and angles are equal, and the diagonal divides it into two equal triangles, and then the diagonals bisect each other. And then the next three bits are kind of the important ones really for leaving cert. So these are the key ones. When you have parallel lines and you have a line going across them, so see the way we have three parallel lines there, and you have two transversals. You see that?
Yeah.
So if I should actually write this out better, but if AB is equal to BC, then that means DE is equal to EF. That's basically what that's saying. Okay. So if the two on the left are equal in length, then the two on the right have to be equal in length as well. Okay. And if they were in a certain ratio, so if you kind of look at the next one, like if B to D and D to A is in one ratio, then the other side will be cut in the same ratio.
We're here.
Okay. And then that leads us on. So the three of them are kind of linked together. If two triangles are similar, then their sides are proportional in that order.
Jesus Christ. Oh, Jesus. Turn it off. Turn it off.
I'm not going to put formal proofs on the test.
It's just you and
did we do the circle? We did do the circle theorems, didn't we?
So, we did a bit.
Yeah, I didn't join the call.
Yeah, the angle at the center is always double the angle at the edge. So if you have an arc and you draw an angle to the middle, and then standing on the same arc, you go to the edge.
You know, it can pick me and
one in the middle is twice the one at the edge. Yeah.
Yeah.
Then from that, if you have the same here, I'll kind of draw them out actually. So if you have a circle. If you draw from the middle and then on the same arc, so if this is arc AB, this angle is X, this is going to be 2X. Okay?
You'll get copyrighted.
And then if you go on the same arc, so if you begin, what it means, begin at A, go to the edge, and then go back to B. Okay? And if you begin at A and go to the edge and go back to B, no matter where the angle is, they're all the same size. So all those angles are going to be the same, and they're all going to be half the one in the middle. Does that make sense? Okay, and then if you have a semicircle, the angle in the middle is 180. So if you start at one end of the diameter and go to the other end, you're always going to have a right angle triangle. Okay? No matter where you go, that's always going to be a right angle.
Yes.
And then the other one that comes from that, if you have a quadrilateral with all four vertices on the circle, so if you've like the 4 points on the circle and you join them up to make a quadrilateral, then this plus this equals 180, and this plus this equals 180. Okay, so the opposite sides add up to 180. So all of those are basically,
this recording is not being put on YouTube.
The one theorem and then what we call corollaries, they just follow straight on from that. And then a tangent is perpendicular. That should be down on
Andrew, you're having according
so if you have a tangent to a circle, then where it meets the circle, that's perpendicular to the radius. Do you remember that? These ones really come in more into coordinate geometry, which we haven't done yet at the circle, so I wouldn't worry too much about those. I would focus on the triangle ones. So what I'm going to do is pull up, let me see if I can find it. Leaving cert one, let me just have a quick look. The similar triangles is the big thing where the sides are in the same ratio. So, geometry. Okay, here's an interesting one. Okay, so just to show you, well, I haven't done this one, so hopefully it works. So this is off a Leaving Cert paper, okay? And what you have is triangle ABC, where CAB, so CAB, this angle here is equal to 90. So when you're doing a question like this, what you want to do is, as you're reading it, make sure all the information is on the diagram. And if there's anything else you can fill it in. So AX is 4, you can see that there. AY is 3. XY is parallel to BC. So I put 2 little arrows in there. So XY and BC are parallel. So I've kind of got 3 arrows there. And these 2 are parallel, okay? AX to XB is in the ratio of 1 to 2. So if this is 4, that means that's 8, okay? That makes sense?
Yeah.
Okay. And they want you to find the length of BZ. So because these, when you see parallel lines, you want to be looking for alternate and corresponding angles. So if this is 90, then this one is going to be 92. So I've kind of marked that in as well, because this is parallel, this is the same line, and this is parallel to this. So this angle has to be the same as this. Okay? That makes sense? And
yep.
What I'm really doing here is I'm looking at my 2 triangles that are going to be, I'm going to see if I can show that these 2 triangles are similar, because if they're similar, then their sides be in the same ratio. Does that make sense? Because that's what our theorem says. So if the angles are all the same, then the sides are in the same ratio. So looking at this angle here, if I do a kind of Z, that's equal to that. And then if I do another Z, it's also equal to this. So these 2 are the same. Yeah. Okay. And then this and this are the same because they're corresponding angles. So you could kind of write that down to show triangle XZB is similar to triangle, so AXY, and that's because, and you could say angle ZXB is equal to angle YAX equals 90 degrees, and then you could say angle this one, so you could say angle XZB is equal to angle AYX, they're corresponding, and then the remaining angle. So once you show 2 angles at the same, the remaining angle will be equal to, okay? So because they're similar, and when you're doing similar triangles, and this is key, put one triangle on top of the other, okay? And put the one you're trying to find out on top. So I'm going to put triangle XZB on top of triangle AXY. Okay, so the big triangle here is on top of this triangle. And the side I'm trying to find is BZ. Okay. Now, which side does that correspond to in the smaller triangle? So BZ in this lower triangle, which side does this correspond to in this triangle? No, BZ is the one on the bottom here. So how you know, when you mark in, the other thing to do is mark in the angles. So see the way BZ is touching this double one and the single. Exactly, okay. So if you mark in which angle is the same as which, then it's easy to see which sides correspond to which, okay? So BZ over XY is the same as BX over, what does BX correspond to? So BX is the double on the right, so that would correspond to...
XA?
Yeah, okay, good. Or I would even say, yeah, XA, good. Now, BZ is what we're trying to find out. XY, now, we don't know it, but we can work it out. And do you recognize if this is 3 and this is 4, what's this one going to be? In a right angle triangle, this is 3, and what will this side be?
Just want to enter over the hot nugget and a baby first.
If one side is 3 and the other side is 4, it's a Pythagorean triple, remember those? 3, 4, and if you can't remember, you can work it out, but 5, yeah, try and remember that, okay? Because 3 squared is 9 and 4 squared is 16. Add 9 and 16, you get 25. Square root of 25 is 5. Okay, so in a higher level maths exam, the more things like that you know, the more time you're saving, because you have to spend a lot of time in these figuring things out and thinking. So the more stuff you know off the top of your head, the more time you have to figure the important stuff out. Now BX is 8 and XA is 4 and 8 over 4 is 2, so BZ is equal to 10. Okay, so if you can find similar triangles, put one triangle on top of the other, and then the corresponding sides would be in proportion. Okay, that's basically what our main theorem is about the triangles. And you have to kind of recognize them. Sometimes they might be inside each other. So you might have a triangle like this, or you might have one like this. Okay. So this smaller triangle is proportional to the bigger one, and same here, okay? Or you might have something like, if this is parallel to this, then this angle is equal to this angle is equal to this, and this angle is equal to this. So you have similar triangles, and they're going to be proportional. Does that make sense? Okay, same if you have it like that. These two angles have to be the same. As long as you're told the sides are parallel, then you can say, well, the alternate angles would be equal. And then that allows you to say the sides are in proportion to each other. And the easiest way to show that is put the triangle where you're trying to find something out, put that one on the top, the other one on the bottom. And that works out that. Is that okay?
Yep.
Okay. Another one I thought we should have a quick look at, because it'll come up in the test, is the probability with the conditional events. So, so just sorry, I had this open, but time's out now. Bear with me.
O zi plângeam, alta oftam. Ei, când te-am întâlnit pe tine, zilele mele-s mai senine.
Chapter 5. So
O zi plângeam, alta oftam. Ei, când te-am întâlnit.
I'll pull up the notes as well, and then maybe we just do a question out of the book. So again, if you go to, this is at the top of the classroom stream, and I have notes and permutations and combinations and notes and probability. And then that worksheet that we did a few months ago, kind of if you run over that, you can still have that done. And I think I had solutions. They should be on the classroom stream somewhere back over. So remember, so this is permutations and combinations. Remember the factorial, where you start at one number and you keep taking away one until you get to one and multiply them. Remember that? So that's for arrangements, and there is a button on your calculator to work that out. So if you're asked, like, how many ways are there to arrange 5 objects, that's 5 factorial. Okay, 5 by 4 by 3 by 2 by 1. Okay, I'm not going to give you any of these N and M's and cancelling things. I'm just going to give you proper problems, okay? And the fundamental principle of accounting is basically if you're going to do one thing N ways and another M ways, then the total number of ways is N times M. And if it's one or the other, then it's N plus M, okay? So like if you have a car in 4 models and 5 colours, then you're going to have 20 choices of how you get your car. It could be like whatever, a Mondeo, a red Mondeo or a green Mondeo or a blue Fiesta or whatever, okay? If there's an or, so if you're picking from 2 things, like how many ways to get a heart or a diamond, then that's add them. 13 plus 13 is 26, okay? And these come into probability as well. So permutations is basically how to arrange things in order. So the number of permutations is n factorial, okay? And then if you only have space for a certain number, like say you have 6 books and you only have space to put 4 of them on the shelf, how many ways can you arrange 4 out of the 6 books? That's 6p4, which is, okay, so how many ways can you arrange? So the ways to arrange n objects, but only taking 4 at a time. That's NPR. So if you have 6 books, but you can only pick 4 of them, that's 6 pick 4, and you just put it into your calculator. 6p4. That's 360 ways. It's quite a lot. Okay, so that's the number of arrangements of your books on your shelf. Okay, is that all right?
Yeah.
Now, if you don't care about how they're arranged, just saying I'm just going to grab 4 books out of the 6 and throw them in my bag, and I don't care what order they're in, then we say, well, those 4 books could be arranged 4 factorial ways. So I take the 360 and I divide it by the number of ways it could be arranged, because I don't care about all those arrangements. And that gives me, divide that by 4 factorial, that's 15. And what that is 6 choose 4. So out of the 6, I'm only choosing 4, but I don't care about the order. So like A, B, C, D could be one choice. B, A, C, D could be another. A, C, D, B could be another. For the arrangements, they're all different, but for the combinations, they're all the same, because it's the same 4 things. You don't care about the order. Okay, so you've reduced, like from 360, you've gone down to 15 different choices. Okay, so combinations are always a lot less than permutations because the order doesn't matter. Okay? Is that all right?
Yeah.
So like, to give you some examples, if you had a committee, say there's 6 men and 6 women, and you want a committee of 5 people, okay? If you don't care how many men or women are on the committee, you can just say, okay, I have 12 people altogether. Out of those 12, I'm going to choose 5. And remember, we can write it like this as well with the brackets, okay? And you just, all you have to do is put that into your calculator. I have 12 people. I'm going to choose 5. So C for choose. So, sorry, 12, choose 5. And that's 792 ways to choose a committee of 5. Now, if the committee has to have, say, more men than women, okay? So say it has to have 3 men and 2 women, okay? Now, I want to choose 3 men and I choose them out of the 6. So it's 6 choose 3. And so for every 3 men, I'm going to have 2 women. So that's a multiplied. And then out of the 6 women, I'm going to choose 2 of them. So there's going to be less ways to do this now because I'm more restricted. Does that make sense? Have you any questions about that? Okay, so that's only, now there's only 300 committees, okay? Now, if you said that on that committee there had to be like a chairperson and a secretary and a treasurer and a note taker and whatever, an accountant or something, whatever, I'm just saying a general person, okay? So say there had to be one person for each of those. So now you care, who do you pick for this? Who do you pick for this? Who do you pick for this and this and this, okay? So now you're saying, well, for the chairperson, I could have any one of the 12. For this person, then there'd be 11 left, then there'd be 10, then there'd be 9, and then there'd be 8. Or you'd be saying, I'm having 12, but I'm more picky now because I care who's doing what job. Okay, so in that case, 12, E5, 5. Now you've got 95,000 choices, okay, because you know you've got different people could do each job, so it gives you a lot more ways to arrange it, okay? So if you care about the order you're doing, you're picky. If you're only choosing them, that's C. So 12P, think of pick and choose. This is more picky. And you're deciding who you care about, what order it's in. This, you only care about who's on it, okay, not about the order. All right. So that's the main thing with permutations and combinations. I'm going to jump to probability. The big thing I want to talk about there is the conditional probability. So the beginning of, there's only one page of notes here, I think. Well, I did a bit more, but we haven't too much. So probability is just chance of something happening. If it's definitely going to happen, the probability is 1. If it's not going to happen, the probability is 0. And you've all that expected frequency. Probability of at least one event is 1 minus 0. And expected value, I don't think we've done that yet. Actually, I'll shorten these notes to fit your notes. Bear with me a sec. You don't need to know everything on this. So I'm going to delete expected value. Now, conditional probability is the really new thing here. Remember, we talked about the conditional probability is when one event has already happened. So it's the probability of B given that A has happened. Okay, and I'll pull up. And then this formula here we used. So, yeah, let me just pull it up. So, if you're kind of skimming over this chapter, the notes, the first bit is just factorials and permutations. The next bit is combinations. And we've kind of looked at the main things you need to know for that. Okay, I'm not going to get into the formulas. I'm just going to say how many ways can you pick or choose these things. 5-3 is just basic probability. And doing your two-way tables or your tree diagrams. 5-4 is just if you're doing an experiment to get the probability instead of just knowing it by throwing a dice or whatever, something like that. Right, 5-5, mutually exclusive events and the addition rule. So mutually exclusive events means they cannot happen at the same time. So if you're thinking of Venn diagrams, there'd be nothing in the intersection, okay? So if you're, if this is your two events, A and B, there's no overlap, okay? So the probability of A or B happening, and OR is kind of like union and sets. so that's P of A union B, is just the probability of A plus the probability of B. Okay, and we talked about OR means add anyway. So if you're saying the probability of me going to the shops and buying a bar of chocolate is, well, probably not so wrong. No, okay. No, you want to count because I haven't got them. So, yeah, if you're picking like the numbers from 1 to 10, say, okay? So in the numbers from 1 to 10, you could have even numbers and odd numbers. So the even numbers.
Did you pause it?
Would be 2, 4, 6, 8,
No,
10,
pause it,
and the odd numbers would be 1, 3, 5, 7, 9. Okay?
Okay.
So that's even and that's odd.
Oh.
So the probability of picking an even number is a half. The probability of picking an odd number is a half. And the probability of picking an even or an odd,
okay, I'll be quiet,
is a half plus a half is 1, because you're definitely going to pick one of those numbers. Is that okay? Now, say you did multiples of 3 and then you did even numbers. Okay, so first multiple of 3 is 3. The next is 6, so that goes in here, and the next is 9. Okay, even numbers would be 2, 4, 6 is there already, and 8. Okay, that makes sense? So now, like the probability, so just say we just pick these numbers, 1, 2, 3, 4, 5, 6. You have 6 numbers there, and we put, if we're going up to 10, okay, we put 10 in here as well. 1 doesn't go in there, 2 is in, 3, 4, 5 is out here, 6 is in there, 7 is out here, and 9 and 10 are there. So there's your 10 numbers, okay? Yeah? So the probability of a multiple of 3 or a factor of 3 is 1, 2, 3 out of 10. The probability of an even number is 1, 2, 3, 4, 5 out of 10. Okay? Now, the probability of getting an even number or a factor of 3. Now we can't just say that's 8 out of 10, because if we did, we'd be counting 6 twice. See that? So the probability of factor of 3 is 3 out of 10. Probability of an even is 1, 2, 3, 4, 5 out of 10. But the probability of E or a factor of 3 is only 1, 2, 3, 4, 5, 6, 7 out of 10. So it's the probability of the first thing plus the probability of the second one minus the probability of the intersection. Okay? Does that make sense? So that's the OR rule. So it just means if there's an overlap, you have to take away the overlap. You don't include it twice. So there it is, the OR, the addition rule. A union B is PA plus PB minus the intersection. Okay? And if A and B are mutually exclusive, in other words, if there's no overlap, then you can just add the two and there's no intersection to take away. All right? Now, then we have the multiplication rule. So if A and B are happening, then we multiply them, okay? For independent events, the probability of B and A, there's, it doesn't matter, okay? So what we have, let me just see. So the multiplication, so if two events are independent and one does not depend on the other. So if you're tossing a coin and rolling a dice, what happens in one doesn't matter to the other. Then you can just multiply the probabilities, and that's called the AND rule. So the things you might see there are dice, cards, pennies or spinners, okay? And you just multiply the two probabilities one by the other, and that's nice and simple, okay? But where it gets more complicated is conditional probability, where one depends on the other. So if you're taking counters out of a bag, so say you start with 2 red and 4 yellow. Let me just. So say you have red, red, yellow, 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 yellow. The probability of taking a red out is 2 out of 6 or 1/3. Okay, that's straightforward. Now, if you don't put that back in, now the probability of a red, given that you've already taken a red out. Okay, so this, when you see the straight line down the middle, it means this has already happened. And now the probability of getting a red has changed. So that's conditional probability. So one thing has happened and that's affected the chance of the next thing happening. So what's the probability of getting a red now that a red has already been picked?
One in 5?
Yeah, good. Okay, so it's a conditional probability. So when you're looking at Venn diagrams for that, there's A, B, this is A intersection B, okay? So you're saying the probability of A, given that B has already happened, okay? So if B has already happened, then this part of A can't happen at all, okay? Because B has happened. Is this making sense? So the probability of A happening is just this little bit here, which is the probability of A and B, and it's out of B happening. So this is the formula that you must remember for conditional events. Okay, so the probability of A given B is PA intersection B over PB. And that's one of the few formulas that is not in the maths table, so you have to remember that. Okay, so I'm going to pick an example out of the book to do. And then we'll leave it at that, sorry. Let's see. Yeah, if you look at example 3 here, so the probability of A given B is the probability, so you've got here, 0.4, 0.1, 0.3, 0.2.
Wow.
Now,
She finished class.
So here's your Venn diagram. Okay, the probability of A given B is the probability of A intersection B, which is 0.1, over the probability of B, which is these two together. That's 0.4. That's 1 over 4. Okay, the probability of B given A is, now we're just looking at this, that's the 0.1 over the probability that A has already happened, which is 0.5, so that's 1/5. Okay. And one of the typical questions, the last thing I'm going to say today, one of the typical questions they can ask is, show, are A and B independent? Okay. And I'll just show you where that is in the notes. Yeah. So for independent events, the probability of A intersection B has to be equal to the probability of A multiplied by the probability of B. Okay? And when you're doing that, what I would do is add these together. So the probability of A is 0.5, the probability of B is 0.4. Okay? So 0.5 by 0.4 there is 0.5 by 0.4 is 0.2. All right, that does not equal the probability of A intersection B. Therefore, A and B are not independent. So if you're asked to show if they're independent, you multiply the full probability of A by B, and it should equal the intersection. If it doesn't equal the intersection, then they're not independent. Okay, so that's what that means there. That's a key thing there, okay?
Maybe just make the ball leave on
If
the
you're asked
surface.
to show if two things are independent, you multiply the two probabilities and show that it equals to what's in the intersection. All right. If you like, I'll just suggest a couple of questions to practice on probability, and I'll throw up a few on probability and on geometry to practice. And the test will go live tomorrow at. Oh, we've class test is until the afternoon. Sure, it's not. So, we can do a class in the morning if you like, or do you have another exam in the morning?
I have an exam starting at like 12. That's along with most of the French people.
So you're going to have a lot to be doing. Look, I tell you what I'll do. I'll come online, and if you want to come on and go through some examples or ask anything that you kind of were stuck on when you were revising, we can do that. But otherwise, you can just study away yourselves. Okay. So I'll come online at the normal time, and if you're free and you want to ask me anything, I'll be here. And otherwise, you can just study away yourselves. Okay. And if you're what I'll do now is I'll put up a few kind of good questions to go over that should prepare you well. And if you want to go through them, we can go through them. Or if you're having any problems, just send me messages. Okay. All right. Good luck, lads. See you tomorrow.
See ya.
Hi. So do you see my thing? As you can see, this thing has fucking subtitles.
On the last bit was I say,
Oh, Aaron joined. What's up, Aaron?
oh, did you fucking hear my mic? That like was. Oh, I was muted. Oh my god.
Wait, what? What happened?